Let's have a look at this. So let's suppose that we have two random variables. Okay? So let's suppose that we have x and y. Okay? Now I've just said that x in this case is the number of siblings. Let me get rid of that. And I think I've said y is the height of each sibling. Okay, so y is the height of each sibling. Mohammed, could you do me a favour? Could you turn the heating off, please? So the control at the back, just literally press the button in the bottom right hand corner.
Turn it off.
Yep, thank you. So let's play with expectation just that little bit more. Okay, suppose we have two variables, we've got x and we've got y. X is the number of siblings that you have, and y is the height of each of your siblings. Okay? Now what I want to do is think now about expectation of these two things put together. So if I was trying to put x and y together by adding them together, so if I was thinking, well, what is x plus y? What if I wanted to take the number of siblings you have and add it to the height of each of those siblings? So let's suppose your height of your sibling was 1.8 and you have two siblings, therefore you're going to get 3.8 if you add those two things together. Okay? So let's suppose we just want to add two random variables together. I'm just going to give you that the expectation of that should be the expectation of x plus the expectation of y. Okay? Now there is a proof for that, but it's beyond the scope of this course. It's actually quite a gnarly proof, to be honest with you, so I'm not going to give you the proof of that, I'm just going to tell you that's true. But can you kind of see from intuition that that kind of makes sense? If you take the expectation of the sum of two random variables, that should be the same as the sum of the expectations of those two random variables. Is that okay? Now what I'm going to do is use this to try and work with the variance. Okay? So otherwise, now what I now want is what is the variance of x plus y? Okay, what is the variance of x plus y? Has anybody got any ideas of where we can start here?
We put them on the power of 2 and plus, so the bracket stays the same, power of 2 plus.
So I think you're along the right lines. Think about what the variance of some random variable has got to be equal to. What's the variance of a random variable? Just remind me of the formula. It's the expectation of z squared minus the expectation of z all squared. Okay? So why not use this formula over here? Like let's just say z is just entirety of x plus y. In which case, this should be equal to the expectation of, well, x plus y squared, variable squared, minus the expectation of that random variable, all squared. Does that make sense? Yeah? Does that make sense? Can I give you 30 seconds? Where would you go next? So discuss on your tables, where would you go next? I want to simplify this as far as possible. Okay, so who's got any suggestions? Where would you go next? What would you do next? That seems reasonable, right? So let's just think about the x plus y all squared inside this expectation. Okay? Let's just expand that out. It's just a quadratic. Okay? So let's change it to the expectation of, if we expand this out, are you happy you get x squared plus 2xy plus y squared? Happy with that? That seem reasonable? Okay. And I guess we could write this, if we wanted, as the I'm just going to leave it as the expectation of x plus y all squared, actually. Okay? I'm just going to leave it like that. Now have a look. Because I've got the expectation of a sum of three terms, so the expectation of x squared plus 2xy plus y squared, surely I can link it back to this thing. Surely I can link it back to this thing, no? Because it's the expectation of the sum of two things. Surely this should just be the expectation of x squared plus the expectation of 2xy plus the expectation of y squared. Yeah? That makes sense? So I'm literally just breaking this up into 3 individual expectations. That seem reasonable? Okay. What else could I do with this then? What else could I do with this? What else could I do with this?
The expectation for x plus y.
Okay, so what could I do with this? So have a look. Haven't I got something? Haven't I got something for the expectation of x plus y? I did that right at the very start. I said to you the expectation of x plus y should just be the expectation of x plus the expectation of y. Right? So why not break that up? Okay? So I've got the expectation of x squared plus... Now are you happy with this thing? Are you happy with this thing? This should just be 2 lots of the expectation of x times y. That's just expectation algebra, which I just told you. So the expectation of 2 times something should be 2 times the expectation of that thing. Yeah? So plus the expectation of y squared. And I told you the expectation of x plus y should just be that thing there. The expectation of x
Plus expectation y and square.
all squared. Okay? Now let's have a look at that for a minute. What do I get if I do expectation of x plus expectation of y all squared? What do I get?
Expectation x squared plus
Yeah? Go on.
2 expectation x multiply expectation y and then plus expectation y squared.
Good, absolutely. It's just literally 2 terms, and I'm just expand them out. So therefore I should get expectation of x all squared plus 2 lots of the expectation of x times the expectation of y plus the expectation of y all squared. Yeah? Happy with that? Now you're happy because I'm taking all that away. Just going to flip all the signs in there. So I'm taking that away, I'm taking that away, and I'm taking that away. Yeah? So therefore I get the expectation of x squared plus 2 lots of the expectation of xy plus the expectation of y squared minus the expectation of x all squared.
Minus
Yeah, minus
2 expectation x
minus the expectation of y squared. Sorry, that's just slightly off of the rejects hiding behind there. But are you happy with that? Okay, you're happy with that. Now have a look. Okay, what I'm going to do is link together all of the expectation of x's. So there's an expectation of x squared there, and there's an expectation of x all squared there. I'm going to write those together. So I get expectation of x squared minus the expectation of x all squared. So I'm literally linking that with that. Okay? If I do the same thing with the y's, I get the expectation of y squared minus the expectation of y all squared minus the expectation of y all squared. Okay? So in other words, that's gone and that's gone. And look what I'm left with. I'm left with 2 lots of the expectation of xy minus 2 lots of the expectation of x times the expectation of y. So I've got 2 lots of the expectation of xy minus the expectation of x times the expectation of y. Okay, so let's have a look at that. Let's have a look at that. So let's just make sure we're at the same place on the screen. Okay, which we are, just there. Now have a look. Are you happy that that bit there, the expectation of x squared minus the expectation of x all squared, what does that look like to you?
Variance.
The variance of x, right? So are you happy, and this isn't very pretty, can I get rid of all of this bit here, just so I've got some more space, because otherwise I'm running out of space. So let's just have a look at that final line. There you go. So are you happy that this bit here is just simply the variance of x? Okay? Are you happy that that bit there is just simply the variance of y? And I'm left with 2 lots of this. Now actually, we give this bit here, so the bit inside the brackets, a special name. We call it the covariance. Okay? So I get plus 2 lots of the covariance of x, y. Okay? Covariance of x, y. Now, covariance is literally just a measure of the dependency of those two variables. So co kind of means together, and because it's covariance, it's how do these two things change together. Okay? Now, are you happy that these two things are independent of each other? Are you happy that these two things are independent of each other? So in other words, number of siblings is independent of the height of each sibling. They're two independent variables, they don't affect each other. So if they're independent variables, would you be happy that the covariance should be 0? In other words, they don't depend on each other. Remember, covariance, I've literally got it there. Covariance is a measure of the dependency of the two variables. Okay? So if you know what one value is, that should give you some indication about what the other value is. But of course, if these are independent, because these are independent, are you happy that the covariance is 0? It has to be 0. Yeah? So therefore, the variance of x plus y should just be equal to the variance of x plus the variance of y, if x and y are independent, which in this case they are. Okay? So if x and y are independent, it should just be equal to the variance of x plus the variance of y. If it's not independent, you have to include the covariance.